Okay, and so today we're going to look at what goes together in sets. And the first thing, in order to understand sets better, we need to understand the symbols used for them. So we're going to look at set notation today. Okay, and so the first thing that we're going to say here is that a set is a collection of well-defined objects. So I might say that the set A is the numbers 1, 2, 3, 4, and 5. So I could say 1, 2, 3, 4, and 5. Okay, and if I want to represent that on a picture or a diagram, we can represent it on something called a Venn diagram. And so a Venn diagram looks a little bit like a circle, or it's an oval shape. And outside the circle, I will write the name of it. So the name of our set here is A. And so there's the set A. Now, the bits on the inside of the set, the members of the set, these are called elements. So these are called elements, the members. So 1, 2, 3, 4, and 5 are all elements. And elements, to say something is an element of a set, rather than writing that whole word, we use the symbol, that kind of E symbol there with a line through it. Okay, and so to represent that on our Venn diagram, well, we put them inside the set, so inside A, with a dot beside each element. So there's 2, there's 3, there's 4, and there's 5. Okay, and if something is not an element, well, then I write the symbol, the same symbol, the E with the line through it, and now I put a line down through it like that. So that's not an element. So for example, I want to go back here and I want to say, well, 1 is an element of A, but I can see clearly that 6 isn't part of it. So 6 is not an element of A. And so 6 would be outside my circle here. Okay, so that's our first basic definition. That 1, a set is a collection of well-defined objects. So they're always used with curly brackets to represent it. So here is our set A, and it can be represented on a Venn diagram here. And the elements, the members of the set, are called elements, and we use this symbol here, and this symbol, not an element of. 6 is not an element of A. So now if I take my Venn diagram here with my set A with the elements 1, 2, 3, 4, and 5, which are displayed here, the cardinal number means the number of elements that are in the set. Okay? So the cardinal number equals the number of elements, and it's represented with the symbol here like the hash key. So I could say that the cardinal number of A is equal to, well, how many elements have I got here in A? I've got 1, 2, 3, 4, and 5. So there's 5 things or 5 elements in A. So the cardinal number of A is equal to 5. So that's the cardinal number. If, for example, I had another set, for example, B, and I can see here that B is an empty circle. It's called an empty set. And the empty set is also sometimes called the null set. And this means basically that there is no elements. So we can see that there's no elements in B. And it's written either with the symbol here, a 0 with a line through it like this, to show that there's nothing in it, or 2 curly brackets with nothing in between. So that's the 2 symbols that can be used for the empty set or the null set. Okay, again, another very important term for us, and they can both be used to mean the same thing. I'm going to take another example here now, and I'm going to say that A is equal to the set 2, 4, 6. And I'm going to say that B is equal to the set 2, 4, 6, and 8. So we can see now that every element in A is also in B. And when this happens, we call that a subset. So when every element in A is also in B, we call it a subset. And the symbol for a subset is a C that's just a little bit longer. So here we can see that all of the elements of A are also in B. So we would write that A is a subset of B. So it's like a C, but just a little bit longer. Okay, and that's our subset. I'm going to look at another term now, and I'm going to look at this term called intersection. So the intersection is if, for example, I have two sets. I have X and I have Y, and bits of them overlap. So here is all of X, and it goes all the way like that. And here is all of Y, and it goes all like this. So we can see here, this bit here in the middle, we have a mixture of the blue and the purple. So that mixture there, that bit here in the middle where blue and purple are mixed together, this bit here, what I'm now colouring in red, this middle bit, that's called the intersection, where they both overlap. And it's written with a symbol like this, like an N without the tail. So we'd say X intersection Y is this bit up here. Okay, and we're just gonna, so if, for example, well, we'll look at one other term now in relation to that first. This time I'm looking at a term called union. And again, I'm going to have two sets, X, and I'm going to have another set Y. So here's X and here's Y. And the union of the two sets is everything that's in both X and Y. All of it shaded. Every single bit. Okay? And the symbol for it is X and this U here like that. U without a tail. So here that's U for union. And that means that it doesn't matter whether the stuff is just in X or it's just in Y or it's in both. Everything is included. So it's all of X and Y. So that means all of X and Y. Whereas over here at the intersection, it's just the middle, the bit that overlaps. Okay, and we're going to look at a quick question and see can we represent those on a Venn diagram. Okay, so here's our question here. We've A is equal to 1, 2, 3, 4 and 5. B is equal to 2, 4, 6 and 8. We're asked to represent this on a Venn diagram, and then we're asked two questions. So let's start with our Venn diagram first. So we'll draw our two circles and we'll label them A and B. And we always start off and see, is there anything that's in common in both? So here I can see there's a 2 in A and a 2 in B, and a 4 in A and a 4 in B. So they're the first bits that I put in. I put in my 2 here and my 4 here. Now, so I just cross them off from both places. And then I look and I see, is there anything left in A? So I can see what's left in A on its own. There's a 1, there's a 3, and there's a 5. And then in B on its own, 6 is left and 8 is left. And that's my representation. That's my Venn diagram there. Okay? Now, the next bit that I'm asked what's A intersection B? So once I've my diagram drawn, it's very simple. I can see A intersection B. Well, that's the bit in the middle. And so that is simply 2 and 4. And I draw my curly brackets. For the second part of the question, I'm asked, what is A union B? So A union B, well, I know that's everything that's in A and B. So that's my 1, 3 and 5, my 2 and 4, that I'm going to write in here, and it's also my 6 and 8. Now that's a little bit messy with these numbers jumbled up, so I'm just going to reorder them with everything in order. You can also see I didn't write down 2 and 4 twice because there was no need. Okay, so all I redo is I rewrite that and say that that's A union B is equal to 1, 2, 3, 4, 5, 6, and 8, and I close my brackets, and that's our answer there. Okay, and so we've completed that question. And so just to go back, we've looked at lots of different notation during the video here. We first have looked at what is a set. So a set is a collection of well-defined objects. Okay, the members of a set are called the elements, and the elements have the symbol E, just like this. If something is not an element, we say it's that E symbol with a line through it, not an element. Okay, and we know that the cardinal number means how many elements, and that's represented by that hash sign there, like that. Cardinal number. Okay, so let's make sure that we have all these notes in our copy, and then we can move on to some of the activities.